The computer converts these numbers into impulses that cause sound waves to come directly from a loudspeaker.
How do you do?
The computer converts these numbers into impulses that cause sound waves to come directly from a loudspeaker.
Well, hello there. Bit of a late one, this one. So what's he up to now? What is this guy up to? We can't get rid of him. What's he doing? Every time we switch the internet on, if you can do that, so you can switch it off, but whether you can switch it on is another story. Anyway, so let's just get on with it. What we're going to do, just some more fun with this simulated waterfall part 2. Yeah, it's got a real waterfall on the picture, and now we've got a simulated one. Okay, number 32. Right, let's just carry on. Well, let's load up the program if I can find it. There it is. So we're going to have a play with this waterfall now. I just realised we were creating a waterfall from a control which was a polygon. It might not be the most efficient way of doing it. Anyway, we need to do some animation with it because we can't poll. We've got no way to poll the radio that quick to create a real waterfall. So we've got this thing from last stream going down like this, and it looks slow. That's because it's doing other stuff, processing frequencies and stuff. So if I do a scan, it seems to speed that up. Let me just do a scan. Because it shut down some of the auxiliary services and just doing some of the stuff. It's processing signal strength only and changing the frequency. That's all it's doing. So it's able to speed it up, and that's just a fixed thing. So all we're doing there is we're changing the opacity and the width. I somewhat scaled it down a bit, and then it returns back to normal operations. So it's scanning for all sorts of stuff that probably hasn't changed. It's just so if you reflect something on the radio, it reflects it on the screen. Let me just see if we got some audio. The width, somewhat scaled it down a bit, and it returns back. Yeah, so okie dokie. So what are we going to do today? So we need to make this into an animated sprite. So what it is, it's an indicator of what is on the frequency. So it's going to sample the frequency. So we'll have to make ourselves a sweep list. So from the selected span, we need to generate a start and an end. It needs to go ahead and change the radio receive the frequency, and take a sample of the take a sample of the signal strength. Okay, and once it's done that, it can use the signal strength to generate sprites across the span. Okay, and that is for a single line. And so we've got to work out how we're going to build this line up. So it needs to build the line up horizontally based on different signal strengths. So we've got to work out that bit. Now it's tempting to use AI and everything, but tends to go somewhere you might not want to go. So how are we going to do it? So I think first thing we need to do is create the sweep. We've got a similar sweep in here for scanning for instance, if we scan that band. So we could use that idea again, or create a new one. We'll probably create a new one, sort of. Oh, we'll copy it. So we'll just go down here and have a quick look. The bands aren't brilliant at the minute. A lot of noise. And I also had a bit of an idea earlier on this section, digital noise reduction and filters. Because we've got a microphone attached and we've got the library for being able to look at the... Let me just shut that up. So we got the ability to sample through the microphone noise. So we could eventually, this is a side quest basically, but to do with the same thing, we could have a selection of filters here, adjustable, and we could have it automatically adjust the filters to create, to listen to the noise coming out the radio, and to silence it as best it can. And you'll have a percentage of silencing. Oh, so it's sort of noise cancelling, basically, noise cancelling. You might say, how do you do that? But it does it by, not by shaping the sound that's coming out, because you're always going to get the audio coming out of the radio, the speaker. So what it does is it alters the filters to bring down the noise, so it can sense the noise. Because we've got a microphone, we've got basically one of the five senses. So we've got hearing. We've given the radio ability to hear through the microphone, and it can adjust as long as I stay quiet. You can have like an auto adjust button. You click it, but you have to maintain your silence while it's doing it. And it will adjust certain things to bring down the noise. So there's that. So this screen will have all the noise and the filters, all the kind of notch filters and all sorts of stuff. Anything that's in the radio already available. But that is a video for another day. So because we're just sorting out the waterfall today. So. We need to, while I'm doing nothing as well, while I'm just listening, there's no point in checking the radio as much as I am for, like say for instance, if I change the radio's mode to CW, so it detects the CW straight away. Now if we're just idle, we're not going to touch the radio. You've got two ways of doing it. You can do the radio and then you need to reflect onto the software, or if you could say, well, I'm not going to be touching the radio, we'll probably have a different mode. We'll have a mode button on here or somewhere, a mode that we can flip. Say the software controls the radio and the radio is a slave, or you have a bit of both, so you can go interaction from both ways, or your radio is the master and the software is the slave, and the software is there solely just to, for login and whatever else you wanted to do with it, a bit of maybe waterfall stuff. So today then what we're going to do is create this sweep thing. So if I click that again, it speeds it up. So we're sweeping and we're going to go from one to the other and create some graphic. But before we do that, I need to get this to do other kinds of graphic. So what I want to do is, rather than just show you the width of the signal strength and center it and draw a little bit of a bar, this needs to be a thinner bar, just basically a line. So we can get more values out of it basically. But the width will have to change according to your span. So your span would change. So when you change the span here, obviously the width is going to change. So and so the signal strength would have to change. Otherwise, it would just fill the whole. It might just fill the whole area up. So once you go on to, if you go on to like from one extreme to the other, like 1000k span, so minus 500 to plus 500 of the center frequency, you've got to scale your signal strength down. Now that signal strength width would be the typical bandwidth for this particular frequency. It can't detect a bandwidth, so you're gonna have to create it with known values. So, for instance, if we grab hold of the band plan and have a look what the normal transmit bandwidth is, we can use that against the span. So if I increase the span, say if it was just a little bit here, say so wide, so when we make the span less, as in go in less, so 10k, we know some of this, maybe a quarter of this, is going to be the width. So then what we want is a difference in the width. So we've already got that now, but we're doing too many pixels at a time. So let's first make that less amount of pixels. So we've got to go to the sprite. We've created some routines already. So we've got some fixed line height. So we've got some line height here. Where are we getting line height from? That's a good question. Where are we getting line height from? We're not getting it from anywhere. So how is it getting line height? Is it it's a global variable. So we can change this value. I'm going to change it to 1. I'm not sure if it'll even be able to draw a single pixel. Potentially it should be able to, but it is the fill. We're using the fill area of it, so maybe it can't do a single pixel. We'll see. Let's just try it. I wasn't going to do a stream. I was a bit tired, so I had went and had a kip. Oh, it is doing a single line. Let's do a little bit faster by doing a scan. It's drawing many lines now. That's just scanning. So with the center scan, we're scanning this and we're staying where we are, but if it sees other signals as it's going from left to right, it would draw the line in the right place. Well, it's not going to be like a water. It can't be as fast as a real SDR radio. It just hasn't got that capability. So, but we can animate. We know certain things about it. We can generate from the span we're on. We can generate a bandwidth based on the signal strength. So yeah, so we haven't really got a bandwidth, but with SSB, at least with SSB, let's just change it back to SSB. So at least with SSB, we can you can know that if your signal strength, it's not really a correlation, but we've got to derive some kind of waterfall with it. Acid Cows, welcome. How you doing, mate? Welcome to the stream again. How you doing? Hope you're okay. Yeah, so I wasn't going to do one, but I thought, well, let's do one, do a bit more on it. Keep just add my bit of a rest. Oh, that's a bit of a weird welcome, isn't it? Oh dear, let's do that again. Try and spell right this time. Yeah, there we go. I don't know if it's me going crazy or this keyboard's playing up. It's got to be me, I think. Doing well, how are we? Yeah, we're okay, mate. Not too bad. We got a bit tired today. Yeah, don't know why. Probably not been having enough sleep or something. But anyway, when I got back from work, I got a little bit tired. Yeah, I love the idea of a simulated waterfall. Yeah, we can't expect an SDR waterfall because we're sampling the signal strength and we're moving the frequency as we sample. And there's even if we shut down a lot of the other stuff, we can optimize it. We can see how fast we can do it, and that's what will create this algorithm now that shuts down other services. So all we've got to do is shut down the service for all the other stuff just while we're going from here to here, one sweep across, and then once we get to the end we can enable it again just for a split second, just to update some of the values if we want to, or if we've got an area of idleness after a while. So if we're not interacting with the radio and there's a period of no activity, it can default to providing all its resources to looking at the waterfall, you know, updating the graphics. But what we don't want is, in order not to make it jerky, we don't want step like kind of thing. We can animate the data. So we're going to make a little bit of a sprite that changes as long as we've got a change from one state. So if we remember the last entry, so the last sample at that particular position, so the algorithm's got to be good. It's going to have to build this algorithm quite quite slowly in order to get what we're after, shape, you know, to get it shaped. Is the idea to audio sample at each point of the scan, get the 3 kHz width of audio strength at each point, then show that as signal level? Not as such, because it'll be sweeping through so quickly. It could be. We won't rule it out, but at the minute, if we do a scan, we're getting this sound effect. This. Again, a little bit. So we've got an audio library in there, so it's possible for us to sample the sound at each point. So we'll keep that as a backup plan. We'll keep that idea. If we can't get enough sort of resolution or changes in at the minute, we can only go what we've got. Now I don't think there's a way of polling bandwidth from the frequency. If there is, all the better. But it's going to be a quick. In order to get the speed to go across from one to the other, we've got to shut down a lot of the interactions. So at the minute we're checking the VFO, we're checking the USB, we're checking the wattage, we're checking the frequency, we're checking the signal strength, we're doing a lot of stuff. I'm kind of thinking of the waterfall you get on WJTSX for FT modes. It's really just showing the audio level at the frequency level. Yeah. I've not looked at any of the other software. I'm new to the digital stuff, so I've only seen what people have live streamed on their thing, so I've not really taken a lot of notice. And from what I can gather, they're directly sampling the sound through an audio interface. So they're putting the radio audio in, and once it's static, you're able to sample the sound. At the minute, this is just doing it through the microphone. The same way it's picking up the what do you call it? The Morse code decoding through the microphone on the tablet or PC, laptop. It's using just the microphone, but you could use another audio input. You could plug it in, but with the FT-891, it doesn't have an audio interface like it as part of the USB. The same as the FT7, the 710 has. It's got an audio. You'd have to buy the digi-rig or something. You can connect a digi-rig. So we'll get this working like this as a simulated one. And if you've got a digi-rig, at some point they'll switch on a setting saying, I have a digi-rig. Then it can do more with it if you decide to do so. I'm only going to go so far with it myself, but because when it's on GitHub as a public project, people can either fork it and do their own, add their own bits to it. I just want to get it fully operational, all the knobs and stuff, with a basic waterfall without any digi-rig or without any extra. What I have is a cheap $10 sound card plugged into the 6-pin on the back for audio. Right. Yeah, I know the digi-rig's about what, 40, 50, 60 pounds or dollars. I'm not sure of the cheap ones. Yeah, so see, in my mind, a sound card is still something you plug into your PC. In fact, I've got one here. That's when I hear the word sound card, that's what I think of. I'm thinking of a sound card, as in one of these. What's this one? A creative sound card. That's what I'm thinking of, but it's probably the same thing in a USB stick. I don't know. So, it is, yeah, sound card. So anyway, I want to do it just the radio, the bare bones. All the digi-rig is a sound card. Yes, yeah. I actually want a sound card for this. As soon as I finish paying for some of the stuff I bought recently, I want to be buying a digi-rig to plug in the back. But yes, and then you can do more with it. It's like look at waveforms of audio and stuff. Yeah, and directly, yeah. It's basically just a way of plugging. I mean, you could just as well, if I'm right in thinking, your extension or your phone's output, you could plug straight into the back of your PC, audio in, or mic in, a line in on you. So really, you could do it that way. But I mean, with the digi-rig and that, it's gonna do a USB. It's like plugging a USB sound device in. So it's just doing it, yeah, more. Hello, Mark. How you doing? Sorry for the distraction. I got a work Teams meeting. Oh yeah, you come and go as you please. No worries. Yeah, we'll catch you as you pop in and out. No problem. Have a good one. Don't work too hard. Yeah. How do, Mark? How you doing? I'm glad you popped in again, Mark. So I tried your FT-891 library, and I did try it. When did I try it? Can't remember. Was it last night? This morning? Can't remember. I tried it, and I got it all set up, and I swapped over from TCP to serial. I worked it on your software basically. I tried to see if I could get something to happen, but it kept saying timeout on it. It kept saying timeout. So I know you haven't got the physical radio, so it's probably maybe it's. I tried your software, and I just swapped the bit out for the connecting to it through a socket with a serial, and it kept saying timeout, and I couldn't, because I know you can move your kit up and down arrow and change frequency. I was hoping to be able to send that out, but I might be getting it wrong. Or maybe it's the interface you've created and the functions are empty. Maybe that was what it is, but I don't know what the timeout was. I was trying to get it to talk to the radio, and it's just kept going on to timeout. So anyway, I did try it. Well, I'll try it again, but I needed probably a little bit of instructional help from you getting a serial working. You never called Connect. Well, I'll tell you what. Let's have a little bit of an intro. I'll keep this on the thing. Hang on, I'll keep that on there. Let me just stop that a second. Let's load it up now. I basically undid everything I did. So I went back to your original. Here it is. I went back to your original demo. In the end, stopped it. So yeah, so you've got your. Hang on, where is this the bit? Yeah, so where this transport is here, I swapped it. I went over to the serial transport. I had a look at this constructor, and I put this in. I put a copy of that in. I put it over here. Where's the original bit? On the program. So I sort of pasted it in here. Very crude sort of thing. Hang on. Let's just stop that back a bit. So what I did with that one, I sort of did this. So hang on, what happened there? So I sort of did this. Hang on, something's happened. What have I forgot? Oh. Must have a return type. Oh, sorry. I didn't save it, so I reversed it back. No, what did I do? I'm just putting the old thing in it. Yeah, so I created a new cat command there. Sorry, let's undo that. Hang on a second. Right, so I think I put it in down. Let's put it in and down here. So I've made a new server thing instead. So a new serial port transport. That's what I did. I guess you made it. So hang on, let me just have a look. Yeah, so I put it in there basically. I wrapped that into there, and I put the port name in as COM8, and I set the baud rate to that and timeout to that. So you've got something here, COM3, expected wiring using variating here. The docs are helpful. Okay, we'll have to look at the docs again. I did have the docs open, I think. So I swapped it out sort of like that, and I think that's what I did. You don't need to set anything other than the COM port, right? Got you. Now, I copied a piece into Gemini, and it said something about the bit rate was not right. You've got to call connect, right? See, it told me this bit here should have been one stop bit, so I don't know if you've done that on purpose. And also on my one, whether this makes any difference, if I go to my serial, the original serial connect, it enables DTR enable RTS and a new line, and a handshake none. So I copied them and put them in, but it didn't make any difference. But so let's just go with what you say then. Hang on, go back to the other one. So we just need the port name, do we? Hang on then. So take everything else out. Yeah. 2 stop bots is what the manual mandates. Yeah, it's just that it only works with, well, don't know if it makes much difference, but we've got one stop bit here. So I did change it from 2 to 1, thinking that might be the problem, but it didn't make much difference. But so let's go back to this one. So once that's in there, you got your cat connect. So that's already in there. So you said something. So you got to do radio connect. So it's cat connect. Is it you're on about? Yeah, you've only had the manual to work from, yeah. So anyway, I did change it to one stop bit. We'll try it like this. So if I run it now, basically, I'll show you what happens. I've closed the other program down. But I never tried it with just that on its own. So basically you got this, and all that happens is it timeout exception. The operation has timed out, and it doesn't show the buttons and stuff. I hard coded it. When you set values, they are overloads. So once you hit connect, it should start listening. Yeah. So basically that I just get this timeout, and I've tried altering the timeout. So that's the cat connect you mentioned. I left everything else as it was. You can't do that. Ah, yeah, okay. I've tried taking this out and it didn't like it, so yeah. Try taking that out. So I mean the stop bit, we didn't get that far because it's just bringing up the it's just bringing that up, and it's waiting, and then it's timing out. I've tried extending it and all sorts, but it didn't. It requires the simulator. It can't connect to the radio itself. It will time out. Ah, got you. Yeah. So I didn't. Then I looked at some of the stuff. Like if you go in here, I don't know if there's anything in there. So peak the definition. Let's just peak that definition. Yeah, so there's some stuff there, isn't there? Unless that's part of the serial stuff. You need to use the CLI library, not the demo library. 2 stop bits. I'll note though. I'll see. I can't detect the right value. Yeah, it's 1 stop bit. As I looked in the manual as well. I think I've seen it in the manual, but it's easy to change. It's easy to change here. Just change that there, isn't it? So what I was hoping to do to see what the response is like with the software, on the actual radio to see what sort of speeds we can get. Yeah, so I don't know where to go from there with it really. So it's I'm a bit thick when it comes to, you know, I can do certain things. It's an interface. It's an interface. You can't abstract it away during negotiating. No, you still can. Yeah. Is there anything I can do with it here now and maybe to get it to see? So we got the server. You start in the server, but I don't know what we're serving. Pull up NuGet console. NuGet. Hang on. Manage the new. Is it NuGet packages? Is that what you mean? Install the library now. Sorry, I don't know. Is this the console? I'm not sure what that is. Sorry, mate. This is without audio. It's a bit awkward, isn't it? Yeah. Yeah, it's a bit awkward. I don't know if this is the NuGet you're on about, but it's the only NuGet I know. I don't know what NuGet console is. .NET add package version 12. So search for. Right, so for search on here. Is that what you're saying? It's a library you install when you just reference it as per the wiki quick start. Right, let's just go and have a look at your wiki again. Okay. Open, copy link. Let's just open a browser. Right, what's it doing? No. Looks like we're gonna have to hang on. It's alright, I'm trying to. It's just playing up this browser link. I don't want to click on there because it'll open up the same browser. I don't use the browser I'm looking at YouTube for other stuff. I use another browser that's yeah, so I don't want that. That'll bring up the wrong browser. So let me just copy the thing and let's get to it another way. Mark, there it is. Right, so we got it over here. So we want look at the wiki. Searching that Visual Studio window you have open. Right, okay. Right, okay, we could do it that way maybe. FT-891.core. Oh yeah, something came up. Yeah, so how does it, so does this find stuff that's on GitHub, or have you published it somewhere else? How's it found it? I can never know how it finds stuff. So let's put that in there. So you've got some information here. Install. Apply. Now is this is installing at the minute into your I've got the it's into yours, not in. It's not into mine yet. It's this is okay into your demo. Is that right? Click it, then install and package it to NuGet for you. Oh, brilliant! That was great. So you did all that today while you was on, or beforehand? No, go to the wiki. Now go to the wiki. Right. Okay. Right. Right, here we go. Find the quick start and you follow it. Oh, okay, brilliant. So we got the TCP socket there. Oh, this one here, yeah. Radio connect. So we don't have to do all that extra stuff, basically. Oh, you did it yesterday. Okay, fair play, fair play. What you can do with it, right? So if we just add this, so presumably that's all okay. I mean, do I add that to your demo to see what we can do, or do I add that? I suppose you can do it either way. But I need to add it to yours first if you can get that working. That's all you need for every call, right? So got ya. So if I make sure you call disconnect, which auto disposes and keeps it down, you can add it to yours now. Okay. Now I had a question for you. While I'm doing waterfall, or I need to shut down the normal procedure. We need like to be able to send the data. I need to stop sending the data back and forth at certain points. Very first line using core, you just reference it where needed. Yeah. Okay. So we put that in our setup. Okay. Now what? Now I've got a loop that runs on mine. It's running certain commands, and every now and again I need to stop the loop. So does yours have a loop, or does it not work that way? Do I have to give a command out and get one back? Because I need to stop the loop at certain things. So as long as there's no loop to stop, I don't quite get, 'cause if I show you the other way, this way of doing it, it's got this on data received event, and we've also got a send serial loop that's going through and sending a load of commands. So mine will listen only for the frames it wants. Okay. So if I want to manage sending, I have to put my sends in a loop. You need to pause that. You can use data channel 2. Pause that you can use, or I can have it raise event flags. Yeah, so what I'm trying to work out is, do I need a serial loop, or a loop in there? Sorry, not a serial loop. I need a loop to send the commands and do the wait states. Because some commands, they need to be done on some commands need to be done all the time, so many times a second, to get the signal strength, for instance. So they need to be in a loop. It needs to send it out. Then there's a receive loop. The handle the cat, once it gets something back, has to then update the UI sort of thing. Yeah. So what I was trying to do is add it to yours first and just see if it responds with the radio. And I don't know if that's possible though, or is that not possible? They're one and done of the most part. You loop the command yourself. Yeah. Okay. Alright. So I'll tell you what we'll do then. I'll intercept. We'll put this one down a minute. Once you call connect, the library is processing all incoming frames, but only taking what it needs. Okay, so right. How does it differentiate? So yeah, so whatever you've set up to receive. So create a new console app and test it. My demo is against the simulator. Got you. Yeah. So yeah, it's tied in with the simulator. Yeah, okay. Alright, so what we'll do then, we'll do what we've just done here. I'm going to reverse this then. Let's reverse it. Actually, which one are we on? Sorry, that's that one. Let's go back to this one. Let's just undo. Have I added it yet? No, I haven't added it. Right, so we'll leave that alone to make sure your simulator's working. I will undo this one here. Get this back to a working state. Get it back onto a TCP socket. That's it. Everything else is the same. Let's just run it up. Do you want me to just build a blank console app for you, so you can just pull and run that? No, we'll try and put it in now, and I'll disable my serial. So that's now running your thing back again. So what I thought we could do is press 1, and then I can change the frequency with the arrow keys and get it to change the radio. But yeah, if that's not how that works, then that's okay. Okay, so we'll leave that as it is. I'll close that one down there, and I'll go into my program and add manage a NuGet. We'll add it to FT-891 core. Right, so we're going to put that one in there and install it. Apply. So we'll get that in there, and we'll do as you suggest. I'll replace my serial. I'll just disable my serial stuff for now, and do it the way you suggest. And we'll try to. We'll start with just changing the frequency, or reading the frequency, for instance. So that's installed. Is it installed yet? Yeah. So installed. That's just showing me what we've got installed today for some reason. And we've got our updates. Why is it not showing? Why is it not showing anything installed? I've got stuff installed already. I don't know what's going on there. Right, let's go on there. Let's just bring up the NuGet. There's other stuff installed here, so I don't know why. Ah, there it is. So there's your core one. Right, okay. Right, okay, so we've got it there. So if we go to the wiki, here's the wiki. So we just need to do this one here. Basically some of this. We'll just copy that over for now. So we'll go over to main window. So init the startup, so we'll get the loop out of there. So I'll just put it in here for now, not like that though. So I'll put it in there, and we'll get rid of this one. It's going to complain a little bit. Maybe we can leave that in, but so it doesn't complain. I don't know. Would not start the command. Right, so we're going to put that. So really that needs to go in. It's going to be quite complicated and long drawn to do it this way, isn't it, at the minute, with all my other stuff in there. So I'll tell you what we'll do then. I'll undo that for a minute, because that is going to break a lot of stuff. So what I'll do is I'll start a new project solution. Yeah. Console app. So I'll tell you what we'll do. We won't do a console app. We'll do a Windows presentation foundation, same as what we're using. Okay. Okay, and I will select the. I'm going to call it Marks FT-891. What do you call what you've done there? It's core, whatever. Yeah, I don't know. We'll just call it that. Okay, and we're going to put it in. Keep it separate from there. Okay. Right, I need to get the right core. See, it's want to try and do the new core now. Target frame to use for the project. It won't let me select the old one, so this is where it got me last time. So we'll have to create it and modify it in a bit. Right. Okay. Let's just modify it once we got it open. Right. Let's change the platform back to 481. Will it let me do that? No. 10 is fully compatible. Okay, we'll do it in 10 for now then. I wrote it in 10. Okay, fair play. Yeah, I'll leave it in 10. Right, brilliant. That'll do then. That'll do. Right, okay. So what we're going to do then is we'll close this down, that bit. We'll have a look at this window. We'll create, just create something. I don't know. Let's just create a button. Let's just call it create a button. Content is press me for NuGet package first. Yeah, okay. Let's add the NuGet package. Add a NuGet package. Hang on. Where's the NuGet package manager? Correct button and disconnect. Yeah, connect button and disconnect. Okay. Yeah, let's create a couple of buttons and a set frequency button. And once we get it in there, we know exactly what we're going to do to, yeah. Yeah, maybe it should go to core 10. It's only because I wanted to maintain some compatibility with what I've learned over the years, but we could find solutions to make it work in this one. Right, so we're installed. Yeah, so we're installed, that's fine. Right, so what we're going to do is create a button. Right, width, say 100, height 50. Okay, we'll have a stack panel. Stack panel, well, orientation will be horizontal. And let's create another button. Okay, margin. Margin, I don't know, let's say 5. No, let's say 10. Just hard code everything for now. It's only a test, isn't it? Right. Horizontal alignment, center. Okay. Main window height, let's keep it small, say 150, that'll do. Width can stay at 600, that'll do. Okay. Okay, right, let's just bring that up here so we can get some room. Okay, that'll do for now. You need to call disconnect or it might not close the connection with the radiator power cycle. Okay, we could call disconnect in the closing if you like, but we won't go to that level of detail just yet. So we'll right, so we'll just call it start. Call it connect and disconnect. And this just set frequency. We'll just set a frequency. We'll just set 14 dot. I don't know, let's say 252, let's say 500. Right, so set the frequency. So we'd have a button click event on here. Mouse down, mouse click. I don't have a mouse click, a mouse down. So mouse down, so we're going to have a mouse. So connect button, mouse down, typo on disconnect. Got you. Yeah, I don't know if this keyboard's all together. Yeah. Right, let's have a mouse down. Okay, let's put another one in. For now, we're just going to have 3 separate. Disconnect. We'll have 3 separate mouse down functions. Won't bother trying to do. Set frequency. Button. That's it. We don't need to do anything with the buttons. So all I've got to do is go down here, go to the definition, it'll create the appropriate thing, and this one, and this one. Okay, so we've got 3 things ready. Let's save it, and we've got to import that using, do I need to using? Yeah, let's put using FT, there it is. Is that enough? No, let's go back to the wiki. So there we go. I'll just copy all this down here for now. Oh, we want that, sorry. Let's get that as well. Yes, you need the using on top. Okay, so we'll temporarily put this down here for now. Okay, it's sort of pushed one of them out of the way, but so we'll have the using. Oh, it's put it up there already, look. Okay, I don't normally put mine at the top. It doesn't matter. We'll leave it there. I normally put it separate. So yeah, let's put it separate, otherwise it'll drive me crazy. I'll just put it there so I can see it. It's different to the main system. Right, so next thing is we need to set up. Okay. So initialize, we could just stick that down there. That'll be COM8. And then we've got radio connect. Right, so it's, oh, hang on. Can I? Alright, hang on. So we need to, I don't know if I can put that. Can I put that in here or no? Can't use it like that, so we're going to have to create a variable out of it. That's okay. So I'll keep it down there, but we need to don't know if we can do this bit. No, it doesn't like that, does it? So it's a new, right, okay. Okay, so don't know if we can get rid of that, can we? No. So, okay, we'll try and make, how do we do this? Can we just radio equals, hang on, let's make a new radio. Don't know if we can do this. Will it let us? Maybe. Right, so we need to reference radio again. Radio connect. Radio disconnect. That should work. Okay, brilliant, brilliant. Disconnect, and to set a frequency, here we go. Alright, so that should, oops. Hi Dave, how you doing, mate? Are you okay? Okay, 252, 500. Let's just welcome Andy. How you doing? I wasn't going to do one tonight, Andy, but I was a bit tired. I went to bed for an hour and then I've got up and had some tea and yeah. So we're just trying this library that Mark's created, so we can get it running bare bones with a simple app. So we're almost about ready to try it, I would have thought. So let's just have a look. We've got a simple thing going on here. Let's just build it. Our build is successful. Should just find that as a startup, I would have thought. Let's try it. Right, so there's your screen. So a bit of a thing there. Right, so connect. Doesn't show you it's connected because obviously we haven't done anything there. Didn't say, it's not come up with an error down here. So we'll set the frequency. I don't know if it's firing, so I'll disconnect and close. Let's just put some stuff in here. Right, so let's make sure it's firing. Well, console, right line. You can check if connected. Oh yeah, right, okay. Okie dokie. Okay, so right, we'll check in this one if is connected. Yeah, if radio is connected. Oops, not that one. Hang on. Right, so radio is connected. Radio not connected. Okay. Right, let's try that. Let's see if we get anything back down here to see if the buttons are firing. I normally have a more complex button than that, but it should be. Should be able to fire it. Right, so have a look down here so we connect. Ah, it's not being fired, look. Not firing that. So our button is malformed somehow. I think it's just click, isn't it? Isn't it just click? Yeah, button click. So I think you do this when you've got other kinds of things going on. Right, so okay, give it another go. I don't use buttons normally. A lot. So connect. Right, so it's not happening down here. That's weird. Right, okay. Right, let's just paste this into. Don't know what's going on there. Hang on a minute, let's just find something. It's just a basic button click, should work. Don't know what's going on. Maybe it doesn't like the framework, or I've done something silly. One tiny sneaky typo and the second button's content. Right. Private static radio core. Sorry, you need to proper constructor. Yeah. It's not saying anything's wrong with the click. It's just not firing. It's, don't know, it's just something wrong with the .NET framework. In the main initialize it will be radio equals new. Okay. So it's not coming up with any error though, is it? Then you do what you're trying to do it right. Okay. Okay. In the main initialize it, it will be radio equals a new. So instead of using, yeah, I got you. Okay. Alright. Okay. Yeah. Yeah, so we're not using, they usually use that within the curly braces to close it and dispose of it automatically, don't they? And yeah. So, but that doesn't explain. So we've got we've got an async button click. Might not like that. Maybe it doesn't like that, but we haven't got to that bit. Let's just see what happens this time. I've got to go nip it off for 2 seconds in a minute. Right, let's see. So connect. Nah. It's not having it. Now up to a few lines. Cat radio becomes up a few lines. Yeah, it doesn't like. Oh, it doesn't like the async, does it? I'm not using async on connect though. Private static. Right, no, I don't think. Well, it wouldn't have compiled, would it, if it didn't know what I was talking about? It's not doing the clicks. So I'll tell you what we'll do. What we'll do then, we'll make a private void init radio. It's not really an init, but we'll just get it to do this, and we'll, once we set the radio, we'll do that, and we'll just connect the radio and send a set VFO, if we can do that. Leave it. I'll write a basic console the UI is trying to solve. Well, I don't use this UI. Sorry, this version 10, so I don't think there's any problem with it. See, that wants an async. Maybe don't need the async for now, just to test it. Let's just do all three without the click. See, actually, we're in the wrong bit. Hang on. Should be in there. Get way to get result on the end. Right, okay. Okay. Right, so, and you can run the async inside a stepwise function. Yeah. So you need to add get on the end of which, on the end of this or this. I've just got to nip to the men's room. Back in a second. Alright. Oh dear. I've never had a button that didn't click before, put it that way. That's a weird one. So, tell you what we'll do. Just take out that a minute from the button click. Hang on, and that. I don't know why it's not clicking. Let's have a look. Right, let's see if it can get the thing to click. Right, so if I press that, no, it's not responding to the click. Oh, I've never known anything like that before. So what is going on? What is going on? We've got a connect, we've just got simple, and we're going to the thing, it's just not doing the event. Throwing a concept together, this won't take, oh yeah, no problem, you carry on. You carry on. Let me just set the width on this one. That'll do. Right. Yeah, I'm more interested in a minute and find out why this doesn't do a click. Right, let's ask you do that. You carry on with that, and I'll. So framework 10 cannot get a click from a button. Click from a button, and it's C# Windows Presentation Foundation. What's going on? It usually causes a disconnect between the example front end and the C# code. Right. Click equals button click. Type click again. Let auto complete. Another element is blocking it. Right. Hang on. Your click events aren't likely fine because you can't see them because of where you are printing the output. Combined with a sneaky UI deadlock startup. What? Never had this with Framework 4.8. Here are two reasons. In an application by default does not have a console window attached. Output won't always show up for the. What? I've never known it. Never known that before. This will definitely show up, right? Okay. Right, anything's possible if you change your .NET framework. Okay. Yeah, I saw it then. Right, okay, so that ran, so let's just copy that to the rest of the stuff. Maybe it is working, but I just want to make sure it's being clicked so the UI is working. That's all I want to make sure at the minute. Okay. I should have tried. Trouble is you have to install framework 4 through 4.8 or something. You've got to go through hoops to get it in there now for some reason. Yeah, you've got to go through hoops to get it in. Just forcing you onto new frameworks. Okay. Alright, so we've got everything in the right place now. Let's give it another go. Okay, so we've got the initial RAM there, look. Why does this keep going to the background? I've lost it now. There it is. Right, so connect. Click connect. Connection clicked. Set the frequency. Port not open. Call connect first. Okay. Call connect first. Did we not call connect? I called connect on the init. So, oh, we were already connected. Oh no, so we connected. Okay. Let's stop doing that one then a minute. Now. Let's call connect. We're not going to do that one at the minute, so we're going to do these clicking and radio disconnect, and then right, okay, let's see what happens now. We've got the clicking going on, so we know the function. Right, so connect, connect clicked, so set the frequency. Hey, you never guess what? The frequency's changed. It changed before. Right, I'm setting the frequency something else, so I'm clicking set. Yeah, it's working. It's working. And disconnect. Yeah, it is working. So that worked, and it changed the frequency. So let's change it to, how do we change it to a get frequency instead? Hang on, let's put another button in. Let's put a label in at the bottom. Okay, so another stack panel, orientation vertical. Yeah, yeah, it's working. So what we'll do is I'll set the frequency, and then we'll get the frequency. And down here we'll put a label. Yeah. So the label. Hang on. X name. Freak label. This will show the rig's frequency. Okay. Oh well, I'll do it. Right, it's a bit light grey. light grey. That'll do. Okay. Horizontal content alignment center. There we go. Okay. After the set frequency. Okay. So we're gonna do a get frequency now. Right, expect bugs but report them. I'll fix them. Oh yeah, brilliant. Thanks, Mark. Yeah, I'll take never touch the hardware. Yeah, you did well considering you never had the hardware to test. Well, there's nothing wrong with it. It's worked perfectly. It's just this .NET Core, whatever it is, 10. Didn't like console. Yeah. But that begs the question, was it stopping it from doing it? Don't quite know. Oh, did we change anything? No. Anyway, so right, we can use it then. So what I'm going to do now is read the so if I await, right, so we're going to set the frequency, and then we'll just put in a, it'll work in your other app, no drama. Yeah, brilliant, brilliant. So I presume there's a get frequency as well. No. Right, so you've got, oh, you get VFO frequency set. Yeah, so pick a function, type radio, and all the interfaces will come up. Yeah, got you. Let's have a look. Get VFO frequency async. So I need to just go like that and get rid of that one. Gotcha. So, and what's it going to return? A long. Okay, so do I need an await on that? So let's just say long L equals. Can we do that? Not sure what happens there. Do we need an await still? So gonna return a long. Oh, tell you what. Let me have a look at some of the wiki stuff. Maybe it's got it in there already. Read meter async. So there's the idea then. I think he's got it. So they're both gets. I equals await. Right. Okay. Got you. Oops. Right, got you. There we go. So we can just go freak label content equals L to string. We've got no formatting, but that's fine. Right, let's await is mandatory. Yeah, got you. Okay, let's go for it then. So when we click the set frequency, I'll change the radio to something else. So we connect, and we're connected down here. We're set frequency, and it's set the frequency, and it's received it there. Look at that, brilliant. And disconnect. So what I need now is another button just to get the frequency. Without, yeah, get the frequency. Right, okay, so we'll get the frequency. Put it up here. Okay, so we're going to move this now over to there. Okay. Oh, we need an async on this. Okay, so now you have a painless lobe. Yes. Yeah, I can see. And what I'm interested in is seeing if I can speed things up. Because it's, yeah, we don't need a loop. Yeah, don't need a loop as such. We can loop it. I want to see if it alters the speed anywhere. Yeah. And it's painless, yeah, so this is brilliant. Yeah, brilliant stuff. So let's do the click. So set the frequency and get the frequency. So I should be able to get it, change it myself and get it, whatever I've changed it to. Yeah, that's it. Oh. Right, so we connect. I'll turn the dial. I'll get the frequency. There's a dial. I'll change it. Yeah, I'm constantly changing the dial. It's working great. I want to meet how fast can I click it. So if I keep clicking loads of times, I'll tell you what. Let's run it in a loop. Let's run it in a loop. Let's pretend we're running it in a loop. So, right. So we're gonna go. Oops. I'm gonna do it from that. For int I equals 0. If I is less than, I don't know, say 10,000. Probably need to go higher than that. 40,000. If I is less than 40,000, I plus. Don't know what this is going to do, but we'll try it. So yeah, run 40,000 times. Let's see how fast we can. Yeah, let's just run it up and see if we can basically. Right, so I'm going to get the frequency and turn the dial. Ready? Port not open. God, yeah, so my fault. Okay, I did a crazy thing. Okay, just make the height a bit bigger. Okay, alright, let's go for it. Promise you might, yeah. Faster than the radio, of course, yeah, faster than the radio. What I'm trying to do, I just want to see what we got capability. Right, so what has happened? So Oh. Right, it doesn't like whatever I've done to it. Right, it doesn't like the way I've done this. Wonder why that is. If I is less than 4,000. Oh, I'm not increasing I, that's why. It's stuck in a loop, so it's alright. I usually use a for each, and you don't need to do I plus plus. No, should do it for you anyway. No, I plus plus is doing it for you. What am I doing? You need to add a weight. Okay, a task weight. Hang on then. Right. Where do I add that? Sorry. And what to what format? Is it just like one I've been using myself? Hang on, let's just open Visual Studio and open the other library. Front end again. Is it just one of my normal weights, task weights? Is it one of those? Don't know if it's one of those. Is that what we need to put in? Not sure. Right, so we connect. Oh, there we go. That's fast as hell, isn't it? Yeah, fast as hell. Let me spin it. You're iterating faster than the radar can handle it. Yes. Yeah, it's working. Anyway, so system threading sleep 100 should be a small value. Okay. Let's try that. We don't seem to have. Oh, system threading thread. Sorry. Thread sleep. So we don't need the await then. Is that what you're saying? Let's try it. Oh, task delay. Yeah, or task delay, yeah. Connect. Right, didn't like that, did it? So okay. Didn't like that, so unless I gotta do a wait. I don't know if I'm mixing stuff here. Yeah, don't like that, does it? Yeah, we'll just use task delay, shall we? So we've got a small one. 5. The operating system can't determine. I don't know if it'll do that. I'll leave it at 5. It works. So we want a loop that we can come out of. Anyway, we've got. Let's just try it again. So we can do stuff. That sounds good. Go with task delay, yeah. Brilliant. So connect. Yeah, I'm spinning the dial with my hand and changing the frequency. If I change the band, there we go. Let's change the band. You can't see anything, but yeah, that's fine. So anyway, I can now put that in there and get rid of trying to derive if it ain't fixed, haven't broke the loop, you can come out of, use the cancellation token info on wiki. Okay. Yeah, I think I used a cancellation token or something in one of these. Which one was it? I'm sure there's a cancellation request token. Yeah, serial loop cancellation token. So you can do something else. Where do we find that? How-to guides. Let's try and search. Can you search a wiki? Cancellation. Right. Down there. What about down here? Transports. Yeah, it's good stuff. This is. I didn't add support for it. Okay. Oh no! Don't do it all at once. Mate. Don't have a. Yeah, don't worry. There's other ways of doing it. There's old ways of doing it. Crude ways. Yeah. So. Yeah, so I'll create. Well, I can use when I create my loop, I can just do it. Hang on, that's the wrong one. Anyway, that's good. So we'll leave that for now then. That'll be for in the morning, and I'll rip out my stuff. We'll have to break it once more until we get all those in place, but it won't be broken for long. So you can give a cancellation token to the loop. So yeah, the serial loop. I've made that anyway. I could probably use the same thing. Right. So task run. Yeah, so I could just do it that way anyway. Some poor sod needs to test every radio function. I will add this stream to the README. Yeah, okay. Yeah, welcome to do anything like that. No problem at all. Yeah, that's good. Yeah, that's great. At least I would love to have the time to create that wiki for my own stuff, but got far too much going on. I could do with not going to work for a living. Couldn't we all? Anyway. Oh yeah, brilliant. Thanks very much, Mark. I think what we'll do now, I'll leave that where it was. Save that. So that's how we set it up. It's dead easy. So anyone can make their own front end. Yeah, no problem. Right, so we'll close that down. Get back onto this one. Let's just run this up. Oh, did I break it? You made my night by testing on a real. Yes. Yeah, and you made my night by it working. You made it work without a real radio. How the hell did you do that? Amazing. Amazing. I'm watching another radio on eBay actually. Oh, Mark, if you're flush with cash, but you got to be careful. You'd sit your RAE if you're in the UK. Get your license. Get your amateur radio license. Go for it. Go and do your join a club or something, unless you've already got it. Yeah, I had mine a long time ago, and I got it all back again. Luckily, I just got it back from when I was already partially on the system, so I got it all back again. Right, so have I changed anything here? No, did I take it all out? No, I didn't actually add it to this in the end, did I? Yeah. Yeah, read the, documentation is key. I used to have a license, I let it lapse. Can't be asked, yeah. Yeah, no problem. Yeah, I mean, there's new stuff going on now with digital. It's not like it was, it's the, you know, they're doing new things, new tricks, old dog, new tricks with it. That's basically what we're doing here. Radios before didn't have a cat control, so you couldn't do anything. Now you've got cat control, you can do stuff with your radio. So you can actually do stuff with your radio. Right, anyway, tonight's stream was going to be fun with Simulated Waterfall 2, but we can still do a bit of that. So we've gone from that window with 4 buttons to this again. So together they'll be fantastic, won't they? They'll be good. So what am I going to do with this thing? What am I going to do with this? Oh no, I need a sip of this drink after that. I need to crack open a champagne bottle. Right, what's next? So we're going to do something with this. So we're going to make a function that sweeps the span and stores. We've already got a similar function, but instead of doing a band scope and storing it, we're just going to yeah, we don't need to store anything like we were doing. So station seek. Here's the station seek that we're transmitting. So that could be made to, yeah, we could copy that out. So what we need to create a new class. We got a Sprite class, and we did have a Waterfall class, I think, somewhere. If I could find it. No, what did I call it? Can't remember the name of it. Oh, Simulated Waterfall. So that's for setting up the display, really. So then we've got a Sprite. I suppose we could keep it all in this bit. I don't know. No, let's create a new one. A new class, right. Add a new class. This one's going to be called a scope sweep, and it's to do with this waterfall. So we call it a waterfall scan or sweep. Waterfall sweep. There we go. I will leave it on internal as soon as keeps pushing it up at me. Right, so waterfall sweep. Okay, so I'm going to just create that constructor. For whatever reason, we'll need to pass in main window. Same old stuff really, we do on every one. Right, pass that in. Oh, it's already done it for me, look, fair play. Right, okay. So we need to copy the station seek. Now we're not going to actually, we're not going to store anything this time, but just need this routine. We'll strip out what we don't want, we'll use it as a building block. Okay, so we're going to call this sweep. I'm going to put all that inside it. Off it won't make no sense. Right, so we need to do certain stuff like stop the scan temporarily. Scanning return. Okay, we can keep that bit then. Right, it won't know what it's scanning. Oh, if we're already scanning, yeah, don't do it again. It's only going to get called. No, we don't need to do that. Right, so that's one way of getting to main window. Okay, but we've done it another way, so we don't need that one anymore. Except for we've called it window instead of main window. Right, we don't need it. We don't need to manipulate that anyway. And we don't need to do that. Station scope clear. No, we don't need none of that. We need to stop the serial loop temporarily. Yeah, so we stop the serial loop. Set RF gain. Yeah, we need to drop the RF gain, so we're going to need port. It doesn't know what port is. Hang on. Serial port. Right, okay. Serial port. So we need all that. Set the RF gain so we can hear something. Alright, we don't need position in the list. Maybe we do. So we don't need any references to UI at this point. Okay. Oh. Perhaps we do if we want to alter the... No. We don't need to alter the button. Right, so we're issuing a command. Hang on, that needs to be down here. Okay. No, didn't like that. What was it? One's port. Oh, dot port. There we go. Last meter reading. I don't need to debug that. Right. Right, so we're going to go start frequency. Let's just I'll just set it in stone for now. Let's start at 14,200. That should do it. End frequency 14,300. Frequency step, let's just say every 1,000. Right, so if last meter reading, activate station. Well, we don't need to do any of that. We just need to get the station seek. No, we don't need to do any of that. So we're sending the command for frequency. It'll then come back. We're sending the S meter. We're asking for the S meter command. So we're sending the frequency. We don't need to send the frequency. Oh, we do. But we don't need to read the frequency because that's only if we want to adjust the display. So I'm not. This is going to be doing it in the background, so I don't need to see it. So we'll send the frequency, and we're asking for the S meter reading. Yeah, that's fine. So the S meter reading will come back in the normal serial loop. So we've got to be adjusting something. Request to stop scanning. Okay, so we're going to need that. Oh, only if it beforehand. Yeah. No, we're going to complete this scan. So it's going to go from one frequency to the other. We're not going to stop the scanning. We're not going to change the. We're going to stop the loop. Right, so we don't set the RF gain once we've stopped. That needs to be done. Start the loop. Needs to be done outside this for next loop. Right, okay, so that can go away. So we've got start the serial loop. Set the RF gain again, we need to do. So we need to do that. And set the RF gain so we don't have to listen to noise. Send cat. Squelch if it's in FM mode, right, okay. Task delay, right. Right, we don't need to do that anymore. We don't need another delay there. We don't need to do that. No, we're not incrementing the loop count, so we don't need to do that. Right, so start the serial is already there. Okay. So yeah, that one goes with that. Okay, so we've got too much going on here. Right, yeah. So what we've got to do now is find out when we issue it an S meter reading in the serial port. Where have we got? S meter. So there's the S meter. And we're going to update the sprite, but we need to get update a global variable somewhere. Where are we doing that? Ah, there it is. No, that's the analog meter. That's not it. So we must be updating meter reading, is it? Right, so are we doing meter reading anywhere? Last raw meter reading, is that the one? So updates stations found. We don't want to add anything to a list view. Update the state, activate, no, don't need that. Don't need the station seek class. If the last meter reading is greater than the signal strength threshold, we don't need to do any of that now. I've added auto task delay to the library. You won't need task delay anymore. Oh, okay. So we won't need to put that in after every instruction now. Is that what you're saying? Brilliant. That'll save a command. We need to be able to adjust that parameter if we can. Have you set a parameter that we can adjust? Because that will be, we're going to optimize that to, well, you know, we need to be able to access that if possible. Easy enough. Right. So what we're going to do now is set the S meter. S meter S. So where am I seeing that in here? There it is, S meter S. Meter to update. That's the meter reading. Oh, the last raw station seek, yeah. So we need a variable in station seek, call that the last. So it's updating that, so as long as we use that variable, we'll be okay. Last meter reading. Which one was it again? Last raw meter reading. Right. Oh, we also got that one. I can be defined, but I'm open to make it dynamic. It will lock the thread until it gets its reply. Okay. Sounds good. Sounds good. Now there is some radio setting for a timeout. Oh, I forget what it's called now. Let's have a look. Cat total timeout. It's on. It goes from 10 milliseconds up to 3000 milliseconds, and I just got it set on 1000, but don't know what that does. Timeout. Cat timeout, and the rate is 3/8. So there's some variables there. Some people have a radio. I mean, I suppose if you're using the app, you'd have to set it to the right rate as the app wants. But they need to be probably variable, really, adjustable, somewhat maybe. Right, so it's needing the last meter reading. So if I just put that there into here, it should do the trick. So this is where we need to do our once we're scanning, we need to use this value here. There won't be a threshold this time. No threshold, because we're just doing it from the ambient noise. Actually, there might be a threshold. Okay, let's give it a threshold, otherwise we'll just see lots of noise going across. Right, so where did I define that? Threshold. Where did we find that? Signal threshold. Where's that coming from? Oh, it's been passed in. Okay. Find all references. So threshold is 3. and 500. Right. So during app startup, you'll be able to call init library. It will discreetly call the radio, get the current channel, then iterate the task delay until failure, then +1 to last good value, and it will tune itself. Or you can overload the constructor and define a static. Okay, yeah, that sounds good. Sounds good. Yeah, some of these setting, obviously, I don't, different speed computers, and don't know, shouldn't really affect it. You could run it on many different things, but you might want to just tinker with it, maybe. Or your automatic tune will probably tune to whichever platform, whichever Windows system it's being run on. Okay, so if it's greater than the main station, right, so it's just, let's just say 7. Right, so we're on Waterfall C. We don't need that anymore. So we're not actually doing anything here like this. We don't need that no more. So we've got this thing in here which is running a loop. So it's running a sweep. It's doing a 4 next. Just of this. Oh, it's just going to go from one frequency to another. So we're pretending. Actually, we don't want to go that full bandwidth. If you're in it, you'll save time on the task delay, especially on decent cables, etc. Good quality cables make a huge difference. Yeah, well, these cables, because for noise reduction, they got a common mode choke, a ferrite choke on them to just reduce noise from the serial data. Even though this one has actually got a choke on this one, yeah, small choke. This is just for it has got a small choke on it. in case there's noise or whatever, yeah. So we've got this sweep. We know we're going into it, we're coming out of it, and this is where we need to do our basically update something. So this needs to be whatever our span is, really. Sweep from the span, so we need a set span. We'll have to integrate that into our spans. So yeah, we're generating a sprite. So we just need a sweep, so we could do with a bar, an indicator bar really. So let me just build that, see if it'll still build. Yeah, so as we're sweeping, we could do with a little red or blue something bar that sweeps from here to there, just so we know we're going where we are when we're sweeping. It might be quick, well, it'll just sweep with it. Yeah, so we need one of these bars, a polygon that we can access and sweep across with. We've got this thing. Let's make another one of them then. Just a visible sweep indicator basically. Okay, so we'll create another one of those bars wherever it is. If it can get, here's polygon. So there's the right. So we'll create another one of these. We'll give it a different colour. We won't colour it red or green. We'll colour it something else. So that's the left hand. Oh, that's a stop indicator. Right. So you've got the green cursor and the red cursor. So I need another one. Right. So we need another one, and it needs to be here as well on top. So we'll just make one. I think we'll put it. Yeah, we'll put it behind these. So I'll just stick it there. Also adding run diagnostic, that will help you test every command available and produce a list pass fail. Okay. Yeah, so we could try it out, and if it create a list of it. Just put a note down. I could probably from your code probably get it working, but I mean, you know, go in and adjust it or whatever. Some of the cat commands are weird, but anyway, I can give you a list of them. Yeah, no problem. So this is not the green cursor, so what we're going to call this then? Sweep. It's a sweep cursor, and give it a colour. Dodger, no, it can't be Dodger blue. That's the waterfall colour. So black, white. I don't know what colour. Yellow. Yellow's a good colour. Yellow. Yeah, yellow on a black background. That'll be good. So yellow. Okay. Let's change the way it does the work. Polygon. So this will be the. We don't need to adjust the length of this one. Just need to move it from left to right. Yellow. So let's just move it away. Where we're going to put it. So now this is the problem. The left position is going to have to be calculated. So we'll go minus 100. There we go. We don't need that triangle. So although they have got triangles, so maybe we'll keep the triangle. Minus 107. Right. Okay. Need to line that up. Oh, we didn't have to touch them, did we? Sorry, we didn't have to touch them. We can go like this. There we go. Yeah, so that one will be long. It'll sweep all the way across. Now, do we sweep from there and leave this free? Yeah, that will free for displaying. And this is the sweep. Okay, we'll keep it like that. But we'll set it at the start. Canvas left, so we're going to have to translate this canvas left business. So we need to go in over 10, 12, 13, 14. There we go. Okay, so we've got this sweep canvas. So we've got to do some clever algorithms for changing this span and knowing where the end is, but at the minute, so we know that's at 14, so we need to find the other end really. So 6. Oh, it's 6. That's it. Bang on. Maybe 613. Yeah. So 614. So 14. So 5, yeah, 600 roughly. Okay, so let's take that over into our waterfall sweep. Now we're going to have to pass that in there. So What are we passing? A canvas. We're passing a canvas. Canvas. It doesn't know what that is. Oh, maybe it's put it in already. Okay, so passing canvas. Canvas. So AI is not doing canvas for us anymore. Did there. Right, so we haven't used this constructor yet anyway. So we get the canvas. Now hang on, do we need both canvases? No, we can just set its position. So let's just put a variable here. What should we call it? Let's just call it a double canvas. Full left position. Pause. That'll do. Equals 14. Full right position is 6 1 3. There we go. Okay. Right, so we're going to use the canvas down here. So actually we just need to go with the sweep. So that just needs to be canvas dot can we just set, I don't know if we can set that. No, we have to do something else. We have to do something. We can't just set its canvas lot. Oh, maybe we can. No. Now we've got to do set left, so we need to know. Maybe we can do that, or we might want to know what the parent canvas is. Let's try it. Canvas set left canvas set bottom. What's that doing? Right. Sets there's no arc given the length. Oh, right. I need to put in the left value. Right, that's fair enough. So we're not setting the top, we're only setting the left. This top is fixed. Okay, so we need to put it in wherever this is. Okay, so it's going to start from there. So we need a separate thing to track it based on the start and end position. Alright, so we're going to do a double, even though it's probably an int, was fine. Double start, canvas start. No, we got standard start. Canvas current position is equal to 14. What's that? Warning me about not using it. I've only just put it in there. Right, so we're going to set left. So we're on 14, so we're going to put that in there. Okay, so we set left, and then we're going to increment this by each one. plus plus for now. We'll just go 1 pixel at a time. So I'll just do an if canvas position is less than, oh, almost did it right then, less than canvas full right position, then do the plus plus, else do nothing, leave it there, and it needs to start over, but that needs to go with the sweep, so it isn't going to go with the sweep, but at least it'll give us an indication. It's not going to go with the increments here, so we need to calculate something there. But let's see if we can get it to move first. So we've got to initialize the waterfall over here. Let's set this up. Let's do it down here. Right, so Sprite. Oh, we've already got the waterfall canvas here. Oh, we've got a new library, so it's a new library. New class. Public waterfall sweep. Okay, as you suggest, waterfall sweep. Is less acceptable than field. What? What's it talking about? What's that all about? Inconsistent. What's it saying? Inconsistent accessible field type. Is less accessible. What's it talking about? So? What's it talking about? Okay. I don't know what it's talking about. Let's do that one. Right, so I'll just type it in. What's it talking about? Must have a variable in there that's unfortunate. Don't know what's going on there. Maybe it just needs to be compiled. Sweep. Some weird stuff in here sometimes. Waterfall sweep equals a new waterfall sweep, main window, and name of the canvas, that one there. That's it. Oh, so that's got to be this. Okay, let's build it. Right, inconsistent accessibility field is less accessible than what is it talking about? Oh, I see. It's this internal bit. That's why I don't like new stuff. There we go, it's gone now. Yeah, okay. It's trying to protect the... Right, so we've got that there. So all we need to do now is do a sweep. So how do we do a sweep? Off a button. So we need to choose a button we're not using. We're using that one for the waterfall. A/B band we're not using yet. Tell you what, let's just use that one temporarily. So we want waterfall sweep dot, what did I call the function? Sweep. Sweep. Okay. Right. We're ready to see what's going to happen? Oh, I don't know. Let's try it. This is just going to sweep the yellow thing across the screen so we can see. It's not going to draw anything. So let's just sweep. Ready? Oh, there it is. It's not bad, but obviously it's stopped already because that's the end of the sweep at 1 kHz step. Because we're on minus 25k, so it's somehow got to follow the span now. So for this kind of thing, I'm going to have to get an AI thing involved because I'm not that good at maths. So I need to track certain things. So when I'm over here, waterfall sweep. Now we need to set the start frequency and the end frequency, so obviously we'll have to put something there. No, it's long, isn't it? Long. Start frequency. Start frequency and long end frequency. Okay, so we'll put those in instead of that. And end frequency. Okay, we probably should put the step in as well. And the step will be, I don't know, what should we make the step? A double step. Doesn't like step. Frequency. Okay, let's have a long then. Long step, right. Okay, so we should be able to set it. So we've got to set it based on, so now we've got to make the scale or the step. Somehow we're going to have to work out the start and end and the step. We know where the cursor is, somehow it's got to track that. So let's make it as easy as possible for the AI to. So we're starting, hang on, current position equals full left. When it starts to sweep, sorry, that was wrong. Full left. Yeah. What else? The S meter reading. Right, so you need a level. Your scan level, so we need to introduce that in there. So you got start for your step and your scan level. Threshold. So let's call it level threshold. and that's going to be in the form of an int. Let's just go on an int. So okay, let's put that in there. So that's where we'll do something else after. Draw something. Create a sprite, but at the minute we're just going to move the... We're going to get the thing tracking right. It's going to be quite complicated because we've got different sweeps and different modes. So we can only accommodate for the center mode at this point. Right, so let's update some of this. So we need the start frequency. So we're just going to put 14.252.500 as a start frequency, and we'll put 14.3800. Hang on, no, it doesn't like dot. 3800, yeah. 380. Oh. And we want the step. I don't know, step 1000, and then the threshold. I'll just make 6. Okay, so that's gonna be that. These need to be brought in from the... Yeah, so we need to work out... Let's put it back in. We need to work out what this span is set to. So need to feed the span into it. So we do a scan. I've got not much drink left. Right, so we definitely got to put the span into it. So how do I do that? I'll NuGet package is updating, so you can update the library, then call var report equals await radio, and iterate the list. It will test every command against the radio. I'm going to bed. Right, okay. Yeah. You've gone down a rabbit hole on this one, haven't you? But anyway, yeah, you created your library. That's brilliant. Sure, loads of people use that library now. They might even update their existing stuff with your library, I would have thought. Because I doubt they would have done a good job like that. I doubt it. They would have got it working a bit like mine, a bit anything to get it to work. I don't know how many people were involved with them, and some of the stuff's getting on a bit now. Some of the software, it might have been, don't even know what they're developing it with. No idea. Right, I'll give that a try. Yeah, no problem. Well, what we'll do is I'll in the morning I'll probably get up early, and before we go out, we go shopping on Saturday, but I'll get up early and do a few hours on it and get it in there and try to replace. I just wonder if I could run it in parallel. Leave the existing structure and replace the commands bit by bit, but yeah, because I would have to break it and do it, but it's not that much in there yet, so hopefully it won't take too long. Yeah, have a good night then, Mark. Thanks for all the work on that one. I'm doing the work here and you're doing it your end. Oh, got someone new. Let's just say good night to Mark. Seeing as he's been working hard on it. And let's say welcome to I4 DFA Sniper, right. Welcome to the stream. I don't think I've seen you in before. Yeah, looking amazing. I have 3. Oh, you've got 3 of them. And this, yeah. Well, you're gonna love this then if you got 3 of them. Poor old Mark hasn't got 1 of them. He's created his library without even a proper radio, just from the cat control PDF or information. To do that without even a radio, and I tried it today and it worked straight away. Once we've got the UI sorted, it's nothing to do with the library. It's an amazing task in itself. Mark's been doing a lot of work in the. I think he says he does back ends or something for systems. So anyway, he's got a library that anyone can use now in there. I think he ought to get his ham radio license again, really. Getting back on, even if it just play with the radio rather than talk. You could just listen, basically. Unless he's done it all before in the past. Each to his own. Yeah, that's good. So you've got 3 of them. Yeah, it does look right, because it's... hang on, what's happened here? Let's just smooth that up again. There, that's it. Yeah, I normally have it on show. So that's the graphics. So we're working on it. We're trying to do a lot of stuff with it. I normally work on different projects. We have a video series, and I just see it towards its natural conclusion. But this one is already half of what made a case for an Amiga 2000 that resized it and modelled it in 3D. That was 65 episodes, so looking like this series is going to be a lot more than 65 by the looks of it. There's so much you can do with it, it's crazy. So basically just get a Windows or tablet or laptop or PC. It's got to be Windows, unfortunately, at the minute. And put in your USB cable, like your printer cable, straight in the back of your radio. And this software will run, but at the minute there is no release version. We're still working on the basics. And I say we because Mark's I was getting in a bit of a strife trying to sort out the cat control library myself, trying to create something, and I realised what a mess the library was. Well, not the library, the information. It's all over the place, but Mark, he does this for a living. I think he does, and he's spent a couple of days on it, probably 2 days, 3 now, 2.5 days, whatever. He's doing wikis and all sorts, so he's created a great thing, and we'll put it in here. He's made it open source, GPL3. This is going to be GPL3 as well, so it's open source. So like anything you run on a PC, it wants to be open source really, because otherwise there could be any kind of malicious code in there. You know, if it's closed source, you don't know what's in it. But I wouldn't expect anyone to. I mean, a lot of people do. They just go ahead and run stuff, and they don't know what it's doing. But this one, it's able to be examined. Thank you. I've watched you on and off over a few different videos, but just wanted to say hello. Yeah, I'm not a program, so sorry I cannot be any help with it. Do you know, you don't always need programmers to help, you need ideas. So any ideas, just come up with an idea. We've got some ideas, whether we can implement them or have the time to implement them, but there's loads of ideas. Get 10 ideas a day, 9 are insane, and 1's sheer brilliant. Yeah, brilliance. Maybe. You and Mark are clever. Oh, no, I'm not a scratch on Mark. I'm a sort of, you know the term jack of all trade? Yeah, worked first time, it did. Yeah, I'm a jack of all trade, and they say master of none, but I'm sort of not. I'm not a jack of all trade. I'm not a master of all. I'm somewhere in the middle, at the low end. But Mark's the master of his trade. Definitely the master of his trade. Yeah, and the fact that he's put all the effort in, and you know, for little or no reward, same as me. I don't want the reward. My reward is getting this working on my radio, and that's basically my reward. And the reward would be if people find it useful, use it. You know, use it. So that's basically it. And it's just going to be free thing, and there's not going to be anyone needing to pay money or anything like that for the upkeep. So we're just going to work on it in a spare time. It's open source. Anyone can look at this code. They can fork it. What they can do is they can go onto a website and they can create a copy of it and work on it themselves and add features. But the whole idea of the open source is to push back any good features they've created onto the original. So we always get a we always get some update, but someone has to have control, otherwise the thing will go wild. So we've got to see if we like the update or not. So you know, anyone can do it's quite weird. I don't fully understand it myself, to tell the truth, but basically if someone modifies it, that part of it, they can add it to your original repository or whatever, push the update on, and you can choose to accept it or not accept it. If someone's come up with something that's horrible, you don't bother. If it's more like it's going to be an improvement. There's not enough man hours in the day for someone to go from nothing. And I've tried to do it. You know, Mark's watched me struggle loads of times, and that's why he's gone out of frustration. He's gone and created this library. Not frustration, but his sympathy more than that. He's watching me struggle with it, and he thought, he told me I can't watch you struggle any longer. So he's gone ahead and done it, which is good. That's what we're trying to do. I'm just making it because I want it. I've got an FT-710. It does all this anyway. I wanted to get into the cat control side of it to see what can be done to do some clever stuff with it that the radio doesn't normally do. So, good night, Mark. Have a good one, mate. He won't be able to sleep now. He'll be thinking of things while he's trying to sleep. Or yeah, no, he's sorted it now. I'm sure he's sorted it. Because he hadn't actually tried it on a real radio up until tonight. We just tested it and we got his library working on a real radio. So yeah, that's good. Yeah, so the radio, we've got so many ideas for it, but at the moment we're just creating, trying to create this simulated waterfall. So at the minute we're trying to get that to track across there. And we've just got a very basic sprite set up. Let's just give it a run, if it'll still run. Every time we add some, there's a chance we leave it in a state it's not going to run. Yeah, so we've got, if I just click, let's click that. So it's just gonna, we're going to do a sweep. Now we're changing. That's as far as it's got, so we're still in the process of doing this, and we've got to track a start frequency and an end. Well, this span here has got to be We're basing this off the FT-710 idea, so it looks, if it looks familiar, it's probably, if you've got an FT-710 or one of the new YAESU radios, it's got similar idea on it with the menu system. As in that, you probably know that one. Obviously this radio doesn't do AES, but we're going to do something with the audio on that after, or replace them for buttons that we can do something with. But we wanted stuff in the same place, so you can click on there and alter the wattage. It alters it there. Obviously updates it there. It doesn't actually send it to the radio yet, so we've got to do all that. So we've got all this stuff going on here, and obviously we've got all this changing the frequency. It goes blurred. It's just supposed to indicate motion. I've got to blur this bit out as well, which I haven't done yet, just to make it look a little bit weirder. We've got some animated buttons. We've got a scope, station scope, so we can scan the frequency. And it's just going to scan the 20 meter band. It just starts from the start of the band and goes to the end. Anything over a signal level strength of 7, which you can adjust up and down. That's your threshold. And it'll stop when it gets to the top of the band. 3800. Or you can stop it now. If you don't want to wait, you can just stop it. And you can have a look down, see if you can see anything. Click around. This one there, so we can add him to this list. Jump around. Try and find some more. It's just looking at signal levels. So when you finish, you just click back to there. And the idea with this list is a quick memory bank list, so we'll have a button that will actually send these to the quick memory bank and actually send them to the radio and store them, so you can actually use the quick memory thing and do it on there if you wanted as well, or just do it from here. Use this to switch, whichever one you selected on, you could use that to switch around. So then we've got the CW. Let's do a bit of decoding while we're here, have a bit of fun. So I'll just turn that off a minute. I'm going to go over to, we've got, this is the digital noise reduction and filter section. We haven't done anything with that yet. In there there'll be all the controls to be able to bring in the current settings. So as you click, it'll send the cat commands to retrieve all those settings and populate the controls. We haven't got them there yet. So this area is fixed, and this area is toggled. So you get your scope, your waterfall and station scope, and your station scope. Then you've got your filters, a CW decoder. So let's see if we can we did some decoding the other night. I'm sure we did some decoding. So let's find some CW. I'm gonna do some DCW at one point somewhere. Let's just change to CW. At the minute, to change the CW, you can't do it on there. This would certainly be a beautiful upgrade to the FT-891. Good night, gentlemen. I'll stop in again in the future and continue to be amazed at your project. Had no idea FT even had the potential. Yeah, yeah, fantastic. Yeah, that's good. That's why I live stream it. I live stream it to show people and get people interested. And I've got one. Yeah, so yeah, come in anytime. Yeah, well, the radio can do it in bits, but to put it all together it's to bring a new lease of life to it, you know, if it needs a new lease of life, but it's still a great radio. It's only 8 or 9 years old. Yeah. Yeah, so let's try and just get some of this CW decoded. Right, start this decoding. Yes, it just picks it up through the microphone. So well, let's try 20 meters. Let's find some moss. A little bit noisy, that one. Oh, let's put it in CW. Yeah, can't seem to find any CW strong signals. Alright, let's have a look on. Let's try it on 80 meters, see if there's anything. No, they're just too weak. Let's try on this one. I don't know what the band is on that. I don't know on this one. Right, let's go on to back to 40, back to 7. Can't seem to find it. There's some stronger signals. Probably too noisy. So it's doing it by listening through the microphone on the tab on the PC, the one I'm talking to you on now. It's just too noisy, I think. Have to find a stronger one. Probably too late in the night. I might have to give that up. Okay, never mind. Never mind. We'll try it another night. We did try it a few nights back, and it seemed to decode some. So there's a lot. Yeah, it's a bit noisy through the microphone. Anyway, so let's. What time we got now? 3 hours. We'll go for another few minutes. So I've got to start from there, and it's incrementing. So it's got to move. It's got to move the step frequency. It's got to move based on the bandwidth, the span. So if I change the span, see that my span is currently, there's no correlation between my span and it does that now and again. We have to sort that out. Oh, maybe we won't have to. That's just the UI, yeah. That's the other thing with the new library. It's tomorrow. If that, see what that does. So we've got our waterfall sweep. The set left current position. So right, so it needs plus the step. Current position plus step. So yeah, current position plus equals a step, or plus the step. Plus equals a step. Plus equals a step. Right. See what happens now. Probably just go all the way over. Well, yeah. Hang on. let me just have a look down here. So we're not doing anything with this, the current position. Oh, plus. So we need to do, well, we'll just go current position and plus equals the step. So increment it by the step. I mean, that's still no correlation between the width, but at least it'll make it across the window. Now we've got to give this function to an AI and tell it to create us a. Have you attempted to use AI like Chat or Grok to write the code? I just asked, and it wrote code based on this video. Yeah, we do that. But what the problem I have is describing what I'm after. So I've created a small little function like this. Create this function so it can understand what I'm trying to achieve without me trying to articulate it to it. Because they tend to hallucinate and go off, imagine, they daydream. So if you can tell it that you want to base it off this, and it can analyse it and see what you're trying to do with it. Basically, that's the idea. Let's see what this does. So it's just disappeared altogether, hasn't it? Oh, it's over here. Ah. Right, so we're back on that again. So what we need to do is, yeah, we're going to put it into AI and get it to sort this out for us, but it needs to track the sweep, which we've not introduced the sweep. We need to bring in here the current sweep. So, sorry, not when I say sweep, I mean the current span. So I've got to find this span late button. Text block span. Right, so that's a different span. So when I choose this, I've got to find the span pop-up. Yeah, that is a span pop-up window. So we've got a border. Here it is. Left mouse button down. Go to the definition. Right, what it's doing, it's changing the span frequency. There it is. We've got so many functions. I only wrote them like last week, but I forgot. I can't remember them all. There's too many. So I have to trace it back again, if you know what I mean, and find it. Simulated wolf, change the span frequency. So let's see what that's doing. So we're changing it from that function. So somewhere, what's this doing? Oh, it's actually doing it in a weird way. It's setting the span frequency. So yeah, current frequency span. So go to the top. Should find a variable somewhere. There it is. It's a static. Still a static. That one is okay. Right. So I should be able to reference that from my other. So simulated waterfall. So based on, if I do, where do I put it? Simulated waterfall. So somewhere we're going to have to use it in here. So if I go simulated waterfall dot current span. Right. So there's the. It's an actual. It's a byte. So that doesn't tell us. That tells us which one is selected. So we're going to have to turn that into. So what we'll have to do is do a bit of a switch statement here. Unless we do a function, we'll put it in here for now. Hang on, maybe I've already got one. I'm gonna have to close some of this. I can't. No. Right, so we haven't. Let me just go to the definition. Right, maybe I've created a function that turns it into something. Scroll pointer. Get the span in hertz. Right, there it is. Yeah, so there's the span. Okay, so we can use that one. Get the span. So there's your span. Okay, so what we're going to do is let's just get the span. Oh, that's I've made that a what's it as well, have I? Hang on. What have I done with it? It's gone again, hasn't it? Hang on, let's close some of this stuff. There it is. So, oh, it's... How has it found it even? It's not static. It's weird, isn't it? That can't be right. So the span, so it gets the span. Oh, why am I putting the span in? That's not get span, that's set span. So we get, oh no, we're passing in the span we want. It's returning us along, that's right, yeah. So what we're going to do is we need to put in a span. And that's it there, so we need to pop that in the span to get us our and it can't do it because let's try it another way. Right, it doesn't know what that is. So we need to find it in our main window. So simulated waterfall. Where are you? There it is. So why couldn't it find that? Spelt it wrong maybe? Inaccessible. Okay, it's public. Hang on. Get span, so that's weird, isn't it? What's it mean inaccessible? It's not inaccessible. Oh, that's weird. Okay, maybe I've made it, yeah. Peek the definition. Yeah, it's private, look. Let's make it public. Okay. So now it should be okay. So we can get the span in hertz. So the start frequency and the end frequency has no correlation. Yeah, we need to do the start plus the span. So the start frequency plus the... So we need to get the... Hang on. So it returns the span. Yeah, we've got to do something clever with a span here. So if I give that to, let's give this to Gemini. Right, let's do what A4 DFA Sniper says. Well, is this Gemini? It's just Gemini, isn't it? Yeah. Right, let's just go back again, have a clean Gemini. Right, so we're going to give it that for a start, and then we're going to give it the waterfall sweep. Right, select all. Copy and put that in here as well. And then, is there anything else we need to give it? Not really at this point. Okay. So I'm going to ask it a question. Right, what we're going to ask it. I need to make the, don't know what it is. Right, so what's it returning again? A long span equals, there we go. So select all. Oh, I've already given it. Shit. Hang on. Can I change it? Can't find it. Okay, let's leave that then. I need to make the, it doesn't know what span is though, does it? This is a problem. This is what I was talking about, how to describe it to it. So I need to give it the code and it needs to work out what I'm trying to ask for. But I've given it some code. I've got to describe what it is I'm trying to do. So all I'm trying to do is make the span, make the for loop track with the span. Okay, let's just tell it that. Make the for loop track with the span. Okay. Dynamic adapter, the span frequency. We need to address how you calculate. Yeah. Okay. Here's how you can refactor. That's a good. Yeah. Keep going. Here's a modified code. I'm getting tired now. Implementing the dynamic tracking. Right. Let's just copy that over there. This is what you do now, just copy the code. And you should have a quick look at it really, but should look at it before you do it, but let's paste it in there. Try and work out what it's done. Total span, it's already put that in, that's good. It's done some calculations. It's kept the start and the other frequency, but how is it handling the set left current position plus pixel step? I don't see how that's going to make it work any better, but right, you never know. Let's give it a go, see if it'll build. Be good if it did work, wouldn't it? Be good. Right, see, when you go to school and learn maths, you need, this is the kind of stuff you need to know, but when I went to school they didn't even have personal computers. Well, they did, but yeah. Right, let's just start it off, see what happens. Oh, it's beautiful, isn't it? It's beautiful. Right, let's see if we can change the span dynamically. Sort of got lost there, isn't it? Didn't. It's probably because it jumped past the end point. Yeah, it was probably just before it. I need to do some protection to say whatever the step is, don't go past it. So 20k. So it works as long as the step is below the jump size. It'll work, but we can do some of that. So that was good, wasn't it? Yeah. Oh, it stopped short there. So wow. What happened there? Stopped short on the big one. Let's try the 500. So it's not quite tracking right. Now, is it because I'm not giving it enough frequency? No, I gave it more frequency, didn't I? Yeah, so span. Oh, well, I'll tell you what, I'll tell it that it's working. Right, so some of them are working. Okay. Let's find out which ones aren't working. That one's going too fast, so below 20k it's going past the end stop, and above 100k it's stopping short. Yeah, so I think 100k was okay. What if you try and explain it by defining the specification? Yeah, I don't know. You've lost me there with that one, but yeah, defining the specification. Yeah, you could just give it all the info. Trouble is, I normally run out of messages because I'm on the free version. But if I explain too much, it ends up just giving me, right just before the moment it says, you've got no more messages, come back tomorrow, it'll say. So it works 20 to 100k. It goes over under 20k, and it stops short over 100k. Right, okay. Problem tracking below 20k, stops short. No, goes past the end stop, and over 100k stops short. I've run out of drink still. These cups, they don't fill themselves up, you know. This math discrepancy happens because of the classic scaling mismatch. When you sweep over different spans, the total frequency range of your loop end frequency isn't perfectly matching the total span hertz variable you are using to calculate the pixel step. For example, if your code thinks the span is 100k but your loop actually runs at 120, it will push past the end stop. If your loop only runs for 80k, it will stop short. To fix this, you should calculate the pixel step based directly on actual frequency distance the loop is going to travel, rather than the theoretical span. Yeah. The fix: modify your calculation setup right before the loop to look like this. Okay, right before the loop. Okay, so let's have a look again. From canvas, current position to the loop. Okay, so canvas current position, there it is, to the loop. Okay, so we'll swap that to there. Okay, let's do it. See what is happening. Normally you have to paste this a few times. It cures one thing, it changes another. But slowly you might get there, you might not, depending on how good the calculations are. Right, let's alright, we're on, we're on 50k, that's the default, so yeah, slightly short, but okay. WPF plus .NET 6 audio from .NET 6 audio from FT-891 USB audio codec at 48 kHz mono 16-bit using MathNet numerics 512 bins waterfall using writable bitmap top down 500 kHz cat class for read MD set at don't know what that, yeah, I don't know what all that is, but yeah, you got some information from somewhere. Set read MD set, you got baud rate on the waterfall, sets frequency near, no pseudo code, no missing methods, no invented APIs, only in audio MathNet. Right, so there's a lot of libraries that produce all.cs as alpha need to compile and run. Is this a fix for the waterfall, or what is it for? No missing methods, no invented APIs only. Right, so there's something, you're saying there's a library that does, what does the library do? Ultimately, sorry, what does the library actually do? Yeah, what's the library do? So that seemed to work. What about, let's get going. Is it changing anything? Looks the same speed to me. Is that anything actually changing? I don't know if there's anything changing. Oh, nothing's changing. Oh, I've done 2. That was funny. Launched 2. Alright, so I don't think there's anything changing on this. No, it's nothing changing. It's not taking into account something now. So there's no change. So when I change the, is it even using it? No, it's gone. It's no longer looking at when I change the position. It's taken a piece out. Right, so no longer changing shit when I change the span. I can't do spelling today. See, it's starting to daydream now. It's taken my thing out. Right, so it's wrecked it now. So what's happened to get span? There's a reason it might not have worked in your original loop. What the hell are you talking about, man? You're daydreaming. I was using that variable to change the span. You removed it. So now the span cannot be changed. God, what's going on? See what? No, you were using that line not just to get it, but because it's the actual variable holding the current state of it. Yeah. Okay, here is a complete corrected sweep method. To check the current span and use the span to calculate. Okay. This is what happens with the AI. You can spend hours doing the same thing over and over again as it daydreams on you. But that's what happens if you don't do your maths at school. You can't calculate it yourself, or you haven't got a first clue how to do it. Right, here we go. So sweep. Change the span. That's looking more promising. Yeah, that's okay. Jump past. It changed speed though. That stopped. Yeah. Okay. Let's go up. Okay, so far so good. Stop short again. Alright, so it's not actually, it's okay below now, but not above. Yeah, it's not okay above. Alright, so it works. Where's the last one it worked at? Right. Okay, so that's good. Now tracks. It's okay. Below. So it's okay 100k and below, but above stops short. Math mismatch. Replace the pixel step map section in your code. Right, this forces kind of stretch. This forces the canvas to stretch perfectly across the available width, regardless of how large the span gets. What? Right, okay. So from there to the pixel step. So we're going to go from there. So change this out. Start again. See, sometimes you can do this for hours on end and then you can just go back to the start at the... It'll actually mess it up at some point and you could have trouble finding the one that worked the best. Slightly short, we can alter that. Right, span, let's try 2k. Oh, no, it's gone back. It's gone back now. It stopped it altering it, look. It's still doing long sweeps. Nah, it's no good. It's no good. That didn't work. It's going around in a loop now. It's actually going around in a loop. This is. That made the lower ones, well, right, so now there is no change. No change when span is changed. I hate going around loops with this stuff. Exact same frequency. Now he's starting to daydream now. Right, so forget that. I'll knock this back to the one that did work better earlier. So I think it was this one. Maybe it might not have been this one. It's the trouble. You got to remember which one it is. Yeah, that seems to work great below. Yeah, so we get to 100k. Yeah, sort of. 200k stops short. Okay. Right, so I think we'll live with that. It's a good start. Well, a good start. So I'll save all that. Okay, we'll shut that one down. Right, so we'll just open the thing. There it is. We'll just put that there, and we'll do A scan, sweep. So we've got a sweep on it. So we can do it up to a certain point. 100k sweep. So I normally have it on 50k. And if it'll do 100k, so it's not altogether too bad. It's doing the 100k. It's doing below. And to tell you the truth, if it's too wide, it'll probably be slow to update anyway. So, but we'll get it working another day. So that's going to be it for tonight, because I'm getting a bit tired now. So thanks for watching, and we'll say goodbye and 73. If you're into that kind of thing. Thanks for watching, and thanks for the input, everyone. And we'll catch you tomorrow or something. Bye for now. See you in a bit.
Just find the right place in the program, make the appropriate change, and we'll run the whole thing again.
Speech is still very complicated. Music is simpler.
Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. The art of leadership is delegation.
That information is not available. This constitutes all available data.
You know what they say, no good deed goes unpunished.